Willkommen zurück zur Games Couch Konferenz 2019. Wir haben jetzt für euch im Stream noch einen letzten Vortrag von Andrew Bell. Andrew, please join me. Hello.
Hey.
Please take a seat.
Thank you. I have my notes, don't worry.
Okay, then everything will be all right. So, you're not a native German.
No, how can you tell?
I don't know, I just know. I know everything because, yeah, I have to know everything. So, where do you come from?
I come from England, in the northeast specifically. Most people know Newcastle as like the city because of football, but I come from like 40 minutes south of there from a place called Middlesbrough, actually. So my accent is slightly different than what you might be used to. But, yeah, I came here 3 years ago for the job at Limbic. I will reveal more in my talk actually as a bit of an introduction, but yeah.
Okay. Then please introduce yourself, because if not, I would have asked you why Germany and why Limbic.
Germany, I'll be honest, wasn't on my radar originally for a place to come to work, just because, you know, it's one of those things I didn't think about. However, the job offer was there, and the company language is English, and it was easy to come over with the EU rules and stuff, as of right now. And yeah, the job fit, the studio was really nice, and yeah, I came over without a second thought actually.
Okay. Yeah. Maybe you come back to this later, but what is a technical artist?
Oh,
because technique and artists are two, for me, two contrasting terms.
They are quite contrasting. If it's okay, I can start the presentation, because I will introduce all of this as part of this. And yeah.
Okay, then just start.
Okay then, yeah, then yes. Okay, yeah, welcome. I'll be speaking about shaders today. They are a kind of magic, but it'll be through the eyes of a technical artist, me. That works, excellent. So let's go over the structure. I will obviously introduce myself again, and technical art and what it is. Especially vertex and fragment shaders. I'll give a quick overview of these things. Then we'll get to the main event, which is the shaders themselves, dispersed with tips and tricks. You will know when you see them, actually. And then we'll go over them again, just to recap. Talk a bit about optimization, as it is a big part of technical art. Some links, and then questions at the end, hopefully. But my agenda for today is to perhaps entice you down the rabbit hole of shaders, because it is a very large world to be in, actually. And hopefully have some fun, actually. So, and again, yes, so that's me at work with a funky t-shirt like the one I've got on. Yeah, I'm a technical artist at Limbic Entertainment. They've been here in Germany for 15 years, and I joined the studio roughly 3 years ago. But it wasn't always like this. In 2008, I was introduced to 3D as part of a college course in the UK, art and design at the time. When I finished that, I went to university, and this is where I got the taste of technical art itself, actually, by being introduced to Unreal materials, actually, in UDK, when it was known as that, actually. And so that's where the path started, really. Of course, I graduated, and luckily I was able to go to a startup called Spearhead Interactive, where we use game engine technology to do VR, augmented reality, actual viz, and stuff like that. But of course, all good things must come to an end. And in November 2015, I came to Germany, and I'm still here to this day. We came to Limbic Entertainment, and in 2018, we shipped Memories of Mars in early access. This year, the studio released Tropico 6 as well. I had a little tiny helping hand with that, but that is not today's topic. So obviously, technical art is something I've been throwing around right now. Does anybody know what this is? Or have you ever heard of a technical artist, actually? Just one, okay, that's Simon, yeah. One other person, okay. Then this is expected, actually. So, the question I get asked often is, what do I do? Sometimes I ask myself that. So I'll try and answer with a visual representation, a fruit basket. Now, bear with me, it's a food analogy, had to get it in there. But what I tend to describe is that each studio has a different need for a tech artist. You'll find that we have a lot of common ground between the skill sets, and so this could be any one of the following, actually. So we could do technical animation, rigging, VFX, pipeline development, engine tools and scripts, and so on. Technical documentation, procedural tools and stuff, for things like Houdini and Substance Designer, shaders, of course. Optimization of said shaders, meshes, textures, lighting, profiling. We are usually in the middle of programmers and artists, but ultimately tech art is about problem solving while balancing visuals and performance. And just for giggles, this is my fruit basket. So I do a bit of shaders, optimization, content creation tools and scripts, and a tiny bit of VFX at the back. So, of course, shaders is the topic. For a super quick overview, these are programs which run on the graphics cards. Vertex and pixel shaders, also known as fragment shaders, are the most common. And you tend to see these in most tutorials and things like that, actually. In some game engines, in this case Unreal Engine 4, these can be known as materials. So as they can do stuff with textures, like use them as inputs, or use them to create and replicate real-life materials like you see on the Cerberus acid over there. Of course, these can range from the very simple, which is just simply passing vertex data in the world to the pixel shader, and as you can see with the multi-cube there, you can just simply multiply a texture with a color, so tinting, but also can go to the very complex. So as in the screenshot you can see from Mars, a multi-layered terrain shader which has 3 or 4 different layers blending depending on where you are. The snow, for example, sparkles. And also there's like an ice layer as well. And also, for example, a ray matching shader, which can trace and create entire worlds without models, or textures. So, and actually, if you want to learn how to do these things, there's a ton of material out there right now. Maybe 5-10 years ago there wasn't so much, but now if you just simply Google Unreal Engine materials or Unity shaders, you will find a lot of artist-friendly tutorials. And I just did a shaders search in YouTube, and this is what came up, actually. But the nice thing about shaders is that they can be universally applied. The languages may be different, and the interfaces may be different, but the same theory tends to apply, actually. You might find some differences, of course. So, today, this is going to be a bit of a bias in Unreal because we use this every day. I just chose to show this in this form, actually. But, of course, we need some kind of subject. And let's find out. So what did I decide to do, actually? A couch. We're going to be looking at a couch today because it's the Games Couch conference, of course. But, of course, not just any old couch. A holographic couch, because sci-fi and couch could be interesting. But why, Of course, it's relevant for the conference. It's kind of a good idea to kind of base a shader, actually, on this, so it could be expanded on quite good, actually. And recently I've been doing hologram-related tasks at work, so it's been in my consciousness, and I thought it would be a nice little thing to do, actually. Also, I wanted to explore a couple of techniques that I've been wanting to do myself. So as part of doing this content for the conference, I'm also learning something myself. And holograms are cool, I guess. But where to start, actually? It's like starting any other project, actually. So like environments, characters, In this case, I just needed to find or make a model of a couch, which we will see soon. But of course, with shaders, you can break them down into chunks when you do research. What I tend to try and do is imagine them as like black and white masks. Don't let color get in the way, and keep it kind of relatively simple, actually. Yeah, and of course, gathering reference, see how other shaders do this approach, or even see how I did it in the past, actually. And of course, we need to identify key features. So, number 1, the couch. This is the star of the show, of course. Some kind of grid pattern, you tend to see these in holograms, of course. I think Fortnite has this kind of hologram background on their pickups, actually. Some kind of rim light, also known as a Fresnel effect. This tends to be something you see in holograms. Some kind of translucency, so you can see through it. But in this case, I will try and do it as a challenge. to use a cheaper technique, actually, to see what we do. So movement, we like to give a bit of life to our shaders, and perhaps a bit of rotation. So, there's our couch. Actually, this month, Epic featured some marketplace content for free. They do this every month. And there happened to be a residential house content with furniture inside. So that's an easy win for me. But when I got this, I already knew that I would only need the mesh and the baked normal maps and perhaps the ambient occlusion. Ambient occlusion maps tend to be used for things like dirt, crevices, and things like that. So it could be used for interesting things, perhaps. And of course, let's go into the fragment shader itself. So the main kind of, let's just say what you see basically. And so, first things first, the rim light. Now, you can put one of these on straight away and it looks kind of cool. And as I said before, it's commonly known as a Fresnel effect. There we go, the notes. And given my research and experience in the past, you tend to see these things actually. A Fresnel is actually based on a real-world phenomenon, actually, called the Fresnel effect. And so the best way to see this effect is on car windows. So when you look at it direct on, like the window, like perpendicular, you don't see any reflection. But as you get towards the grazing angles, you will see some more reflection. And yeah, this is known as the Fresnel effect, actually. Unreal Engine 4 has a handy node for this called the Fresnel node. But of course, this can be done as follows if you ever do this outside of Unreal, like in Unity, for example, or if you want to try and recreate this yourself. Excuse me. So there, sorry. So you can see that in this case, it's just a power node, so you get kind of like a curve, but and with a dot product, which we'll find out soon what this can do. And then you kind of invert that, basically, and you get this kind of white kind of edges around the edge. You can customize this, and it's pretty cool. But, of course, that means we come to our first shader tip of the day. Number one, the dot product. This thing is very much a part of a tech artist toolkit because it can be used to compare vectors, for example, like three component values, and it outputs a scalar between -1 and 1. So you would see this actually as like a circle usually, and you can see that, for example, blend shading model, the simplest shading model that we know from 1977 when Jim Blind did this. It's just a dot product between the vertex normal, so the kind of, let's just say the way that the vertices point, and a light, which as shown here I trying to manipulate. And then you just make sure that this is a positive value. You may see some variation on this, but it's still there. So, for example, if both vectors are parallel to each other, the product is 1. It's white. And if they're facing away from each other, this is -1. And actually, other techniques contain a dot product, but we will see those soon. So, translucency, to be or not to be? That is the question. Since it's a challenge to use dithered opacity, which in our case is here to spread the gradient out so that it's almost like proper translucency, but more performance, sorry. Excuse me. You can see in the bottom right-hand corner there that it tends to look like some kind of noisy pattern. Printers tend to do this as well. And you tend to see this in a lot of post-process, actually, because they tend to be very noisy, and so they try and blur them. And in our case right here, I don't know if you can see that very well, actually, the Fresnel in this case is just plugged into the opacity mask. And in our case right now, we have a material option for this. And so this gives us this thing. However, because it's opacity mask, it tends to be like a 1 or 0 kind of binary value. This is subject to a threshold value, which you can see in the bottom left, actually, in the red. Anything below this value is discarded, so think of it like the threshold adjustment thing in Photoshop. However, this material option is not that customizable, at least from the user's point of view right now. And it's, of course, made with a particular anti-aliasing method in mind. But we also have another solution out of the box. It's called the dither temporal AA, which is another solution, and actually it's a material function as well, so you could look inside of this and see how it's done. However, this might not get you the desired look. So for comparison purposes, from left to right, we have the dithered opacity mask material option, And then in the middle is the material function node with this random parameter set to 0. And then the last one is set to 1. And of course, you can get very differing looks. But one thing to note here is that anti-aliasing can really affect how this looks, actually, especially when it's in motion. So one thing you should do is test this when in motion and also with anti-aliasing on and off, so to make sure that it works. But what if it does? What if it doesn't meet expectations? What if it's not what you desire? What can we do? Why not make our own dithering pattern, actually? And so, does anybody recognize this kind of image, actually? Yes, there's one person. Oh, and there's two, one at the back there. Excellent. Maybe 3 or 4. Okay, yeah, that's okay. These are UV coordinates for the screen, actually. So, screen UVs, in this case, they might differ depending on the render itself. So, Unreal Engine 4, for example, has the green channel going downwards, so the green towards the bottom and then 0 towards the top, whereas red channel tends to be universal. So be aware of this. Now, we want to move our origin from the top left-hand corner, in this case, to the middle. And why we'd want to do this? So the original is subject to screen size. So if you change the viewport size, for example, then whatever effect you use for this, it will scale and look weird. So for example, if you wanted to do a circle, it would squash and stretch. And in this case, you would, this enables that so that you can have any kind of shape and it wouldn't be affected by the screen changes. And so this brings us on to our second shader tip of the day. From 0 to 1 to -1 to 1 and back again. I'm trying to get a little hobbit thing. So remapping, this is also called, actually. Going from to and from 0 to 1 is quite a common thing to do. Normally, you can do this with normal maps. So these kind of baked, kind of extra detail things. This operation has to be done behind the scenes, like on a texture level from a GPU kind of thing. But if you pack them and unpack them yourself, then you will do this. And of course, doing this with height maps will also give you a greater range to work with. And it's just an example of a 0 to 1 gradient going to -1 to there. So you kind of have like a mirror line in the middle, potentially. However, to note, in Unreal Engine 4, there is a node for this, but the way that this is done is slightly different to what I'm going to explain right now. So to do this, let's just use our UVs as an example. We multiply it by 2 and then subtract 1. And if you're going from -1 to 1 to 0 to 1, which is the opposite, you multiply it by 0.5 and then add again. So like I said before, the constant bias scale node does this a little bit differently because it adds the value and then scales them both afterwards. So there's some values there that help with this, actually. So the default is actually from -1 to 1 to 0 to 1. But the other way around, you put the bias as -0.5 and then the scale is 2. So I actually worked this out by doing the maths itself rather than looking visually in this case. So now that we have our screen UVs and the origin is at the middle like you would expect on like a 2D graph, we need to apply aspect ratio correction because of the problems from earlier. If you still, in this case, still resize the screen, it will squash and stretch anything that is tiling, for example, and you will see this. So let's apply this correction here. I'm not sure how much you can see of the node graph there, but just to go through it, what you do is you multiply the red channel by the horizontal resolution, and then you divide that by the vertical resolution. And in this case, this resolution on the x-axis and the green axis division is in this handy little node here called the tan 0.5 times field of view. But if you wanted to do this yourself, you can take the view size node and just divide those two inputs, actually. And of course, this applies aspect correct ratio. And although visually it may not change that much, behind the scenes, as I've said a few times now, and in our case, actually, the dithering will stay the same size. So, for example, if you're moving away to and from an object, it will stay the same size now, rather than being rescaled. It's depending if you have, for example, different quality levels of screen resolutions. So, on a lower-end machine with a lower resolution, your effect might look different if you use the screen effect. And now, of course, with our screen correct, let's make some noise. And in our way of doing this, Yes. And it's still quite small, actually. So what you do is you can pan your UVs, so you can shift them along a single axis, or in two in this case. The disconnected ones at the top, that's the panner node, which is how Unreal Engine 4 wants you to do this. But if you're doing this outside of Unreal, of course, you can just add a time multiplied by a speed value, and then add that to your original UVs. But to generate the actual noise, we have to multiply, in this case, in the simplest way, is to multiply it by a very large value, add another very large value, and then take the fractional part of this. And you get this kind of noise pattern that you can see here. Unfortunately, GIF compression really doesn't help with it, but it's still the same kind of idea. And then, of course, this is still in a kind of two-channel value, so you get red and green values. But we want a grayscale out of this. And so this brings me on to my next shader tip, number 3, the length and distance. So if you input a vector, you basically get a grayscale representation out of this. So for example, a good way of doing this is you get a kind of a desaturate kind of thing. And actually the sphere mask node in Unreal Engine 4 is this. And I actually found 3 different ways of doing the same thing, because that's what happens. Normally I combine this with, for example, if you compare the world position with the camera, you get this kind of cool, almost kind of area effect around the player. So, now that we have our noise, I wanted to show you the static versus the moving version of the noise. And hopefully the GIF does it some justice. Yes, it does. Excellent. Here, I decided to actually go for the static version, because for me it looked a bit softer as the effect. So, yep. And then, of course, with our ambient occlusion map from earlier, this kind of black and white mask, we multiply this on the top so that you can see, for example, more of the crevices in here. So, now, I hope we're on the same page so far. Hopefully it's not too technical, but this is one of those parts of the job that, it is quite technical, of course. So, next thing is the vertex shader, the other half of this, shall we say, for this effect. And it's all important in this case, because for us, there are actually 2 ways of doing this in Unreal. I've highlighted these in red and green. Yes. For scaling and offsetting vertices, you use the world position offset node. Inside of Unity, I think they have their own little struct thing that you can do this, actually. Excuse me. And for example, if you're doing potentially math-heavy calculations, you can stick these inside of your customized UVs, so to speak. So these extra kind of places to put this calculation. And the reason this is cheaper sometimes is because you have less vertices than pixels in this case. But today is all about the world position offset, the thing that's highlighted in green. Now there's a word of caution here, actually. If you move vertices, this does not affect the bounds of the mesh, because a mesh has a bounds and also has collision and so on and so forth. This does not affect this. So for example, if you scale them too much or move them outside of the bounds too much, you may actually end up culling them, so making them disappear without intending to. So the thing to alleviate this is to extend those bounds artificially. So you add extra, so for example, if I was to manipulate this couch and it had some bounds like here to here, and I was, squashing them or stretching them, and it was, disappearing, I would actually extend the bounds of this mesh artificially. So, and of course, we wanted movement in our shader, and in this case, the sine wave comes to the rescue. And because it's only in one direction, we only have to feed it into the blue channel. So in the bottom right-hand corner, you can see that, for example, if you take the sine wave of the time, so this kind of, it's motion that you see from school, like these waves, almost like sound waves, because that's what it is. This provides a value between -1 and 1. Now, the problem with this is, of course, it's past the point of 0, so we have to either remap this or clamp it so that it never goes below 0, because a lerp requires, the alpha requires a 0 to 1 value. In this case, the values are in world space, so in this case, it's centimeters. But this brings us on to our next bunch of shader tips, 3 of them. This is getting a little hairy. First and foremost, the sine and cosine. Now, if you remember your school mathematics, Like I said, this is kind of like a wave almost. But when you combine this with a time parameter, it makes almost like a pulsing effect, actually. And as with mathematics, they are used, for example, for rotation in very complicated ways, actually. The next set of ones are lerp. So, as I mentioned earlier, this actually uses an alpha mask, so a value between 0 and 1, to blend between two values. In this case, black and white, red and blue, etc., etc. It's what they call a linear interpolation. This is super common to see inside of shaders because you want to blend between this material and this material using the height map, for example, of another material. Another one is clamp. So this does exactly what you might think it does. It clamps between two values, and it works exactly like the levels adjustment layer in Photoshop. The most common, of course, is between 0 and 1, and actually this is supported on the hardware. You might see this word called saturate in code sometimes. This means that it's actually clamping on a hardware level. And this is free sometimes, so it's good to put in. And last but not least, I kind of put it into the same as the clamp because the smooth step, for example, creates this almost like S-curve, but it also clamps between 0 and 1. It's kind of become a bit of a favorite of mine to use sometimes. And depending on what you input and which order you put them in, for example, the min, the max, you swap them around, you can get some very interesting results. And it also gives a bit of nice contrast as well. So, next thing. We are moving in one direction, in the z-axis in this case. Now for rotation. Now rotation, I will say this, it's hard. At this point in time, I'm still learning about rotation because normally you tend to see it done with like multiple matrix transformations, so like a bunch of numbers multiplied and add together. But luckily, once again, Unreal Engine 4 has a few nodes to help us with this for rotating in 2D or in 3D. And today we're interested about this one particular node called rotate about axes. So as you can probably imagine, it rotates about one axis in this case. So once we've done this, once we have our inputs, so for example, in this case, you can take the world position itself, like the absolute where it is in the world. However, if you move this, or move the actor itself, because everything has a pivot point, if you move this, then you get this weird effect of it looks like it's increasing as a radius, so it gets further and further away than what you intended, actually. So if you, for example, subtract the position of the actor or the object, you can use this pivot point as like a point of rotation, actually. So you can use it with many different meshes, for example, or that kind of thing. So it's very flexible. And the rest of the inputs, so like pivot point is the original, and the axis is the z-axis, which is the blue channel in this case, and then our rotation angle is the time, with a bit of a speed factor. But how do we combine this with our previous translation, the sine wave? We simply just add it, actually, which can be, that's the kind of solution that can be as simple as that sometimes. But as you can see, our rim light looks a bit weird. It doesn't look like it's following the camera anymore, it's following the mesh, which it shouldn't do, actually. Actually, this would be more obvious if we had normals and if it had like default lighting, for example. It's not aligned to the screen because the vertices are moving in such a way that they do not match their original way that they point anymore. And the vertex shader itself doesn't update this information. It doesn't need to, actually. So how do we get around this? By rotating the normals as well, so doing the same operation effectively twice, but by using the normals, so the baked information in this case, as a basis, so that it follows the same rotation on both the vertex level and on a pixel shading level in this case. Of course, Unreal Engine 4 has another material function for this called fix rotate about axes normals, so does what it says in the tin. Yes, but of course, every star has a co-star usually, and ours needs some kind of source to project the hologram in our kind of world. And in this case, we're going to do a sci-fi pedestal. Bizarre. So there are 3 components to this, actually. There's the cone, as you can see, which is kind of like glitchy. There is the grid, which is slightly moving and has this dip, as I call it, and of course the base pedestal itself. Now, the base and the cone, they are very simple shapes actually. I didn't have to do much modeling in this case. A normal cylinder, which you can do as a primitive, with some extra curves in the middle, and simplified a bit more. And I also modeled in like a dip in the cylinder itself. The cone is another type of cylinder with another set of curves so that it goes in on itself. And what I did to get this effect so that you always kind of see the inside is flip it inside out. So the actual model is inside out. So you will always see it from like a weird angle and it looks like this. In terms of materials, there's not much going on for this as well. The base is just a very simple metallic material with just a bit of roughness, a bit of simple color, nothing to it really. But it's really reflective, so it looks cool. The cone itself is using a simplified version of the couch hologram itself. I actually turned off a couple of features so that it just has this glitchy gradient. Also, it looks kind of similar to the couch, but it doesn't turn or anything like that, so none of the more complicated things. Yes. Now, the mask, or the grid in this case. There are several ways to do a grid procedurally. In the last shader project I did, that was at a conference, I found 3 ways of doing it there, and in this case I found another 2 ways of doing this, actually. There are several main components to this, and I'll just walk you through it from left to right. We take the world position, and we take the kind of the flat plane, basically. This is very common for like UV-less models, so you can texture without worry about seams and stuff like that. I then multiply this by a tiling value so that it's bigger or larger. In this case, a smaller value. I then move this across so that you get some kind of movement. It's not so, I would say boring, but you know. And then we take the fractional part of the value, and this gives us a nice repeating pattern, actually. Now, the next bit is the most important part in this case. It gives us this, well, grid-like effect. So normally if you see some kind of if statements, like say if this value is above, I don't know, 0.5, then it's a value of 1 or 0. But there's a cheap way of doing this. If you multiply or add these repeating values, and then you do this operation called a floor or ceiling, which is just rounding up or down depending on, you know, if it's a floor or if it's a ceiling. And then you just take the length of this, so do the dot product of itself and take the square root. And that gives us a nice grayscale value. Now this last part on the right after the frac is for the border style and width, basically. You could you know, make this kind of customizable, basically. Now, as you can see, there's like this dip in the middle that is kind of synced up with the couch movement. And what I did to do that was just to use the same time function that I did. So just take the time, put that through a sine wave with a period of, I think was a 6 in this case. And then I remapped it so that it's always between 0 and 1. And then feed that into our linear interpolation so that it kind of goes between 2 world values. In this case, just 0 and then going down. So it gives us our effect. But if we did this without a mask, it would do the whole, in this case, the whole circle, and it would go up and down like this. And to create this mask, we go to our good friend the distance, in this case the sphere mask, and just take the original pivot position and do a comparison with the vertex normal, so like the thing that's actually pointing up here that meshes have. And then we just, you know, multiply the vertex operation with this, and this gives us our little dip in the middle. So, and there it is. When you combine all this together, you get this, I think, kind of funky-looking holographic couch, actually. To kind of give it a bit of extra fluff, I added a bit of bloom in the post-processing, so I had a bit of kind of glow. So a bright color so that we can activate the bloom, make it glow. And then we have a bit of fog and a light in there as well, because otherwise this wouldn't actually emit light, it's just a very bright value. So, to recap, our shader tips for today was the dot product, remapping between 0, 1, and 1, and back again, the length and distance, the sine and cosine, the lerp, the clamp and smooth step, which is becoming a favorite of mine. But of course, there are other common things that you can do that shaders tend to do as well. And in some cases, they tend to match up with what you might find in Photoshop. So min is a darken layer, max, which is a lighten. The frac, floor, and seal, these are good for example, frac repeating values. Floor and seal, they tend to give you like binary values, so like 0 or 1, so it's a very hard calculated value. Multiplying everything, this tends to be also a thing we do. Add, which is also known as linear dodge inside of Photoshop. I'm sorry. But also what you can also do here commonly is add the time to the UVs in this case, and as I shown earlier, the panner node. So it kind of pans across. And one last thing is inverting values, so 1 minus this. So for example, if you have a black and white mask here, you then invert it, white is on the top, black is on the bottom, for example. And of course, I cannot talk about shaders without talking about optimization. And this is something that we've been doing a lot recently at work, actually. So, say for instance you have several grayscale textures, up to 4 perhaps. You can try and combine these into the individual color channels. So instead of thinking of textures as colors, you think of them as just places to hold grayscale values. This is known as channel packing. And normally, what you tend to see is when it comes to physically based rendering, you have, for example, metallic, roughness, and ambient occlusion inputs. You tend to see these packed together in a certain way. So, for example, the red channel is metallic, roughness is in green, and ambient occlusion is in blue. So it looks a bit strange from a visual point of view, but of course the data is used correctly and it still is okay. Now, the reason that you tend to find, for example, roughness in the green channel is that it has an extra bit, in this case literally, an extra bit of information, so it looks a bit better while working with compression. So if you combine this with channel backing and doing some very funky masking out areas of UVs, so taking a gradient, multiplying it and then flooring it, you can actually mask out different parts of materials. And I did this actually for our UI recently. I took 8 masks in different textures and managed to compact it into one texture by just doing this technique of masking out certain areas and feeding parameters to this. And last but not least, in this case, you should make a test environment that is easy for you to access, because you will test a lot of things. And the screenshot is of my test material, and it's got some comments, and it's got a very handy name as well, Limbic test face, so I can always find it. Some more notes, actually, is to check your buffers and values. So in Unreal and Unity as well, you have these view modes, so you can see exactly what you're inputting sometimes, what the lighting looks like, what it doesn't look like, for example, this kind of thing. There's quite a few in Unreal Engine, for example. And this also includes having diagrams of common mathematical operations. So for example, the dot product is just 2 3-value numbers multiplied and added together, for example. And once again, Unreal comes to our rescue with material functions built in. For example, you got these things called debug scalar values. So if you need to see them as numbers rather than as visual representation, this is also good. And another one is a plot function on graph. So what it does is it literally puts a graph onto your material, and you can see what happens in real time. This is really good, actually. And comments. Comments are both important to you and anybody who touches the shader. Now, make them count, because otherwise you run into a situation where you get the comment like in the screenshot. I don't know if you can read this, but I will read this out almost exactly. This is a calculated value. Speak to the tech artist. Depending on opacity, this is a specific curve. And guess who wrote this? I did. So it's not very useful at all. Luckily, I was able to sort that out. And last but not least, if an operation can be done in a multiply-add operation, so if you multiply a value, then add it by another, the GPU will actually like you for this, because it can do this in one collapsed, optimized instruction. There are some links here. I'm not sure if I should keep them up for the moment, also, if you take a screenshot if you want. But I will also share these a bit later as well, when I release this project. And so, final thoughts. You will have surprises, as I found out today as well. Some good, some bad. Be persistent. Sometimes you don't get it right the first time. And so if you keep trying and trying all sorts of crazy ideas, you might come up with something that's quite unexpected, actually. If you can use existing code or existing nodes, use them. That's what they're there for. That's what they've been made for. Shaders is a huge world, as I said earlier. And there's usually more than one way of doing something, as demonstrated today by making a grid, for example. I seem to have left in an old sentence. Although all the features were actually implemented, I can actually come back to this. So this point is still valid. So this can be expanded upon. Like, for example, you could have like a tiling kind of screen-based, lines effect. Some kind of weird glitchy effect added onto it, depending on, of course, expectations and time as well. Keep learning. This is really important as tech artists because the industry moves at a very quick pace. And if you're not learning all the time, then you will get left behind. And so this can have a really detrimental effect. And last but not least, sleep well. Trust me. Doing this presentation taught me that lesson again. So, my links. I have a Twitter, which you can all follow. I tend to retweet about graphics-related things or some other cool things as well. I have an ArtStation, which is /T-Sider. Be careful, there are 2 S's in the name. Also, you can just search for Andrew Bell. I'm on there as well. And Limbic are hiring, actually. We are hiring for level designers, console programmers, and senior ones, game designers, senior game designer, assistant producer, and internships. And of course, if you go to our website, /jobs, you will find more information about each and one of them. Thank you very much for listening and having me today. Are there questions?
Yes, are there questions?
Right in the chat, there are no question about really complex, really mathematical theme. I think was good presented, but a bit hard to understand.
Yes.
But really good job on your side from my standpoint. For general, we have got a host, so thank you for that. And for all additions, we have evaluation that you can join on Google Docs. I have the link in the chat, and you can also scan around here just for your information. And then back to you.
Any questions of you? Don't be afraid. You can ask in German as well.
Yes, I will try and understand.
Okay, then to be honest, shaders are really a kind of magic to me. I had totally no idea what you were talking about. I'm so sorry, but I have the deepest respect for what you are doing. But the question I was asking myself is, how often or how much time do you spend actually on working and processing, and how much are you just problem solving and just improvising, and how often do you achieve the perfect solution?
Oh, that's a very, very good question, and this actually can depend from week to week, depending on what tasks I have, of course, in production. Improvising, that can be very sporadic, but like problem solving tends to be, right now we have a lot of optimization efforts on the game, so there's a lot of problem solving, how to balance texture quality or quality in general with performance, and actually creating or doing the stuff itself. Like this week and for the next foreseeable future, I'll be making shaders actually. So yeah, it really depends on month to month, depending on what we've agreed on, of course, with production.
And how often do you, kind of work messy on purpose to achieve a more realistic look?
Well, when it comes to things like this, in terms of like looks of a certain thing, this is usually discussed with art or the art director to try and meet expectations. I test a few ideas out that I might already have. I'll see how other shaders have been done in the past, or not in some cases, and just kind of push through it, suggest ideas, show them to the team, get feedback on that, and it's like a very iterative process. In terms of the messiness, the test material is very, very messy, but it's just for me, actually. I have areas where I worked out techniques, and then I implement that properly for for gameplay or for code and stuff like that. So yeah, it tends to be the message just for me.
Okay. We have a question.
Yeah, we got no question. So he asks, someone told me to use switch parameters in Unreal too much because it's quite expensive. Is that true?
This is a very good question. So there's such a thing called static switches in Unreal Engine where you can effectively turn off features or remove them for cheaper platforms, for example, like low-end mobile devices, and yet still have the same material. Depending on how many you put in, it can really increase how many different combinations of shaders that it has to compile, because, for example, it has to say, oh, I have to do this for this feature, but then I have to do it again, but without this feature. And so when you're compiling shaders, these permutations, these variations can get really, really large, and so many, depending on how many different switches you use. What you can do instead is just use a different material and then implement the same features perhaps, or just change it. And there are certain material types or shader types that you cannot turn off, for example. So there is this thing called tessellation, which can subdivide vertices on the fly based on the hardware and how far it is in front of you. In Unreal, you cannot turn this off with a static switch, for example. You have to use a different material. So, yeah. There's also something similar called quality switches, which can do kind of the same thing, but they're for for low quality settings or for medium, you can do the same thing if you wish, actually. So there's a few options.
Thanks. So there's another question. I just read them because it's better than if I try to paraphrase them. So the question is, should a complex shader networks as the one shown in the talk be used in the future with ray tracing in games on the horizon? The computational payload of such shaders would explode, if I understand it correctly.
Okay, so what I've shown today, at least the dither opacity, is actually quite cheap to do. So you can do it on, I think you can do it sometimes on mobile devices, for example. But for ray tracing, I honestly don't know yet, because I haven't been able to play about with these new graphical features which are being, all over the industry right now. So I don't know until I test that, actually. But extending it with these ideas that I have today, or I've brought today, it shouldn't be that much extra than the initial cost of using ray tracing, actually. So I hope that answers the question.
Yeah, thanks.
We have a question here.
Since there are a lot of students in here, it might be interesting to know how you became a tech artist and how do you prepare, how do you build a portfolio for such a thing, which is so wide,
Yeah, so as I said, every studio actually usually requires something different from a tech artist. They want different things. So one might, for example, want a technical animator that can do rigging and stuff as well, whereas, for example, Limbic didn't want this. They were looking for someone doing shaders and optimization and such and such. In terms of portfolio, I would really try and tailor it. So, for example, if you're going for something like my position, then obviously show some shaders. For example, some height-based shaders, this kind of thing, like for snow or for moss or something like this. So very kind of specific scenarios. In terms of how I got here, and how I got into tech art, the story that you tend to hear is that you tend to fall into it. You don't necessarily mean to fall, to do it. In Spearhead, actually, I was doing a lot of different jobs at the time, and then it kind of eventually became more of the tech art stuff. So things like doing materials again, optimizing materials, like combining textures together, doing things what they call level of detail models, things like that. So this can be sometimes done as well. I got really interested in this based on the original kind of university exploration I did with materials back then. And yeah, I just kind of continued with this for scripting and tools. I actually was interested in doing programming, so I was self-taught. It took me a long time to get to that point, but as soon as it clicked, it kind of was okay. I'm still learning to this day, of course, especially programming. I always ask my colleagues something. But shaders, I'm always learning as well. As you say, as the question was, there's ray tracing, which is an entirely newish thing, for the games industry itself, but for films, it's been around for a while now. So it's exciting times for sure.
Okay. Thank you so much for your time.
We had one more question if we have time.
Yeah, but no, Yes, okay, we have time for one more question.
Okay.
Okay. So regarding channel packing, is there a difference between the channels for the example in compression?
Oh, yes. There is a difference. This is based on, it depends on the type of compression. So, for example, the usual type of compression is DXT. And the red channel, in terms of numbers, has 5 bits. The green channel has 6, and then the blue has 5. And then the alpha has 8. And you tend to see important roughness or grayscale-based things tend to be put in the alpha channel. But using this extra channel, of course, means extra memory cost as well. So this you have to be aware of as well. Yes.
Thanks for your detailed answers and insights.
Yeah, no problems.
We have a small present for you as well.
Oh, it's a little couch.
Yes.
I should make this into a hologram. Yes.
And some chocolate.
Oh, dankeschön.
Gerne.
That's my German for today. Yeah. Yes. Yeah, thank you for having me, actually.
Yeah, it was great. Thank you. Just lay it down. Thank you. Also wir sind jetzt am Ende mit dem Stream für heute und deswegen wollen wir ganz kurz nochmal die letzten Sekunden oder Minuten nutzen, um den Beteiligten zu danken. Das ist vor allen Dingen Erik. Vielen Dank für die Chat-Moderation, dass er euch so schön begleitet hat durch den Tag. Und genau. Labor 10 für die Technik. Außerdem der Fachschaft IEM fürs Essen. Und natürlich herzliches Dank an das alte Hallenbad für die Location. Und auch an alle Speaker, die sich die Zeit genommen haben, hier den jungen Menschen ein bisschen was mit auf ihren Weg zu geben. Auch ich verabschiede mich. Es hat mich sehr gefreut, dass ich hier heute Moderatorin sein durfte. Wenn ihr ein bisschen mehr über mich erfahren wollt, könnt ihr gerne auf meiner Seite vorbeischauen, gammarepublic.de. Ansonsten wünsche ich euch noch einen schönen Tag. Wer den Anfang verpasst hat übrigens, der Stream wird auch hochgeladen wieder im Nachgang. Schaut einfach vorbei und ansonsten einen schönen Abend noch.